Okay, so hey everyone, it's me, Shomik Devnath. Now, I'm going to discuss about my project, which I did recently, and it is called the Clustering Anthropometric Profiles for Custom Workstation Design. So, what is it actually? So, as you can see here, that designing ergonomic workstations that fit all users is a challenging task due to the diversity of human body measurements. As we humans have different body types, different width, different height, and every features. So that's why it is very difficult to make an overall estimation that which type of ergonomic design or feasible ergonomic design that we will be able to produce. So that's why I decided to make or work in this project. So this project applies unsupervised machine learning, which is K-mean clustering, to identify the distinct group of individuals based on their anthropometric measurements. So what I did here and what I have aimed here is group individuals with similar body proportions and visualize differences using PCA plots, radar charts, and Shewett scores, as you can see, and also ultimately support the design of customized user-specific workstations that enhances comfort and safety and performance. So let's get started. So here are the necessary libraries that I have imported. So as you can see here, I have imported like the Plotly, the Pandas, Matplot libraries, and so on for the visualization purpose, of course. And secondly, what I did that loading the main data set, the data set that I have collected from my university and what I've been working on through this project. So here is the main data set. I have stored the data set in this folder of mine. Then here's the main data set as you can see. So this is the compiled sheet that I'm showing you right now. So it total consists of 7 groups actually. So here as you can see, group 1, group 2, group 3, group 4, group 5, group 6, and finally group 7. So I have compiled all these sheets from the 7 sheets, and which are these sheets as you can see, the group 1, so group 2 and group 3, group 4, group 5, group 6, and finally group 7. And later on, that's a blank sheet, as you can see. So yeah, that's not the main concern. So okay, so back to my project. So here I have loaded the main data set as you saw right now. So I have defined the full expected columns that what I'm going to work on and what actually my data set contains. So as you can see in my screen, there are roles, individuals, serial number, age, weight, BMI. These are all are available in my data set. Let me show you here. So where's my data set? Here. So here, as you can see, like a group, role, individual, serial number, age, weight, then BMI, stature, eye height, shoulder, elbow weight, etc. So here you can see the same thing as well. So here you can see eye weight, shoulder height, elbow height, etc. So I have added all of these so that my code can identify that what I'm actually working on and what I'm going through. So yeah. So now here's the loaded and alignment of all the group sheets that I have showed you previously in my data set. And what are those group sheets? The group sheets are these, like a group 1, so group 2, group 3, group 4, group 5, group 6, and lastly, the group 7. So in my code, as you can see, I have mentioned all the groups here, like as you can see, the 4 groups, group 1, group 2, group 3, group 4, group 5, group 6, group 7. So here in this code, I have specified that which sheets am I going to work on right now. So I have like put all these sheets together in my code, and then after writing the code, then I have like run the code. Then after running the code, I have to combine the samples, and which are 234 samples, all combined, all from my data set. Here, like from this data set, the samples that have been found are 234, which are huge. So Now, selecting ergonomic features. So mainly in ergonomics, what we actually look for to design a specific product that we really want to design for our comfort. So uh, there are some few tribes that we actually look upon and then decide that based on those characteristics, what we should design actually. So here are these: ages, weight, BMI, stature, then shoulder breadth, hip breadth, the thigh thickness, and the vertical grip reach. So these are the common factors that we usually judge during ergonomic features. So that's it. So now the normalization and clustering. So now I'm going to normalize all the values in my data set for clustering purpose. As you can see, I have used the standard scalar. And why I have used standard scalar? Because I want to normalize all the data that I'm using for the purpose of this project. So it transforms the values to have zero mean and unit variances, of course. So sorry. So this step prevents larger numerical features stature and weight, which I have in my data set, from dominating the clustering process. So after normalization, the k-mean clustering algorithm was applied to group individuals into three distinct ergonomic clusters based on their similarity of their body measurements. So these clusters represents the groups with shared anthropometric characteristics, which are useful for designing inclusive and ergonomic products. So now I'm going to talk about the PCA for 2D projection. So actually, well, what PCA stands for is Principal Component Analysis, PCA. So, and it has been used to reduce the high dimensional anthropometric data into two principal components. So allowing for a clear 2D visualization, this dimensional reduction technique preserves the most important variance in the data set. So as you can see, I have specified the PCA components and what I'm going to work for, and I have written all of these in my code, as you can see. So here are the visual clusters that I have generated by my code, and here's a generation of the graph, as you can see. So here are the plottings, and the plottings are titled as cluster 0, cluster 1, and cluster 2. So what is actually cluster? Cluster means the similarities in the data sets. And in my case, the similarities of cluster 0 is based on the tall and average build. And the cluster 1 is based on the average height and slim build. And cluster 2 is based on shorter and heavier build. So how have I recognized that what the cluster 0, cluster 1, and cluster 2 are based on? I have realized from this. Let me show you, and it's in the last of my project what I did. So here are the like radar chart. That from the radar chart, I have realized that what actually cluster 0 means, and what actually cluster 1 means, and what actually cluster 2 means. All these I have recognized because of the statuses that it contains, and the the situation that I'm seeing in front of my screen in the graphs. So from those, I have realized that what actually cluster 0, cluster 1, and cluster 2 means. I'll come to this further. So let me just, show you what I'm talking about right now. So as you can see that in this PCA projection, what I'm going to tell is if these clusters are, less or what should I say? Like, um, where's the visualization again? Yeah. So if the clusters are overlaps, so look at in minimal range, so it means that it suggests that high cluster purity. And what actually high cluster purity means? High cluster purity means that each group contains the individual and similar body measurements. So, and also if there is some overlaps, like here, as you can see here, like some of these are getting overlapped, the green dots, like, which means the cluster two. And what it actually, the overlapping means is that the natural variation in body type, first of all, and secondly, it is possible that need for a different number of clusters. So it might need more than three clusters, perhaps. And also, there are need of more features and are needed to capture the differences as well. So, moving on. So, the PCA projection and also the PCA 2D and 3D plot projections overall assessment or the interpretation are kind of the same. But still, I have added this in the beginning because I wanted to make a, like a discrete introduction of PCA projection. So that's why I wanted to talk about it for like in the beginning. So that's why I have put it in the beginning of my project, kind of the beginning into my project as well. So yeah. So now I'm going to talk about now is the cluster-wise average profiling. So what I did here actually is the specification wise like averages that I have conducted, like as you can see for cluster 0, 1, 2, 3, there are various specifications according to my data set, which are like the age, weight, BMI, stature, shoulder breadth, hip breadth, and so on, as you can see. So all these numbers, as you can see, or the numeric values, as you can see, are the averages, which I have like conducted for like a detailed assessment. So here, what I actually wanted to say by like cluster-wise average profiling is the cluster-wise average profile summarizes the mean values of key anthropometric features within the each clusters. So the analysis provides the insight into the physical characteristics that defines each group, such as the average height, weight, BMI, and so on, as you can see. So these profiles are essential for ergonomic applications. And as they help to identify specify the needs of each user groups, the designing products workstations gets much easier. So now moving on, I'm going to talk about the Shearer score visualization. So in Schuler's for visualization, we have to keep one thing in mind. Not one thing, several things actually. So here, if the high score is closer to a one, which you can see in the like Schuler scoring, there's Schuler coefficient. So if the coefficient is near to one, so what that actually means is that it is the clusters are well separated and cohesive, which is a good thing actually. So in case of my interpretation, what I have realized from my graph and analysis is that the majority of the data points have positive Sheward values and suggesting that the clusters are well separated in my data set that I have showed you previously. And second of all, the average Sheward score is above zero point 0.5. So as you can see here, all the Sheward scores and the graphs that you're seeing here are all above zero point 0.5 or kind of not necessarily like really above, but nearly kind of cross zero point 0.5. So yeah, it is like more than zero point 0.5 and enough. So yeah, it's a good thing. So and also lastly, if one cluster has shorter bars or more variability, it may contain more diverse individuals, potentially needing a closer look or even reclustering. So as you can see, that there are some bars, like what should I say, like this one. This one I would imagine like, let's say it's five. I guess the cluster label is five. So here it can like its bar is kind of short. So as its bar is short, that means that it has variances in case of like individuals, like or the diversity of individuals. So that's the thing in case of like sheer visualization and scoring. So moving on, I'm going to talk about now the PCA 2D and 3D plot. Not necessarily here is a 3D plot, but I have managed to do the 2D plot. Oh, and I have like previously talked about it and what are the clusters means and everything and so on, and what are the clusters, each and every cluster actually defines cluster 0, cluster 1, cluster 2, and So I'm going to skip this. So finally, what I'm going to tell is talk about is radar chart for cluster profiles. So it is the most exciting part of this project. Like exciting, like it's exciting for me because I love the analysis here. So let me show you. So here in this final analysis step, like I have used the radar charts to visualize the means values of anthropometric features of each cluster. So each clusters, one we're going to talk about is this. Like I know it's kind of like whole bunch of details and like in the beginning it kind of like overlapped each other uh, but afterwards I'm going to show you the fresh version of it. So here as it but let me talk about this stuff for a while. So actually what I'm like seeing in the radar chart is the variations in case of various segments and the diversity what it carries on. So here in the normalization charts for cluster profiles, I have like made the fresh version of it in case you're like confused by seeing this stuff. So I have made it kind of easier for you. So to highlight the relative differences among clusters, I have normalized the anthropometric measurements. So these radar charts reveals distinct body proportion patterns for each clusters. So such as like the variations in statures, BMI, and grip reach and shoulder breadth, like the main things that these like clusters and the radar charts are indicating. Like overall, I have like normalized this stuff in order to make it a fresh version of visualization, which I have absolutely did here, and you're gonna see it now. So look, what do you think? It's very much fresh, right? Like the main features that has been like pointed out has been like given here and like cluster wise. So cluster 0, cluster 1, and cluster 2. And what do you actually realize by seeing this normalized radar chart of cluster 0? The stature unit is maximum, elbow height unit is maximum, and the shoulder breadth is also maximum, along with the vertical grip reach. So it indicates the what I've talked about previously is, or is it like the tall and average build. So all these features literally indicates the tall and tall builds naturally. So straight units, elbow height maximum, and then shoulder breadths are also maximum. Vertical grip reach, like reaching the maximum height. So it's obviously indicating a tall guy or a tall human being, right? So from this chart, I have realized that what actually cluster 0 means. So that's why I get to put this here, right here, tall and average build. And then cluster 1 indicates average height and slim build. Remember, average height and slim build. So let's see if the cluster one chart also indicates that as well. So as we can see, the stature unit is also like medium or above medium, and also the elbow height is also medium, and thickness is in here. So the shoulder breadth is also medium, and the vertical grip reach is maximum. Uh, so yeah, obviously it's indicating that there's an average height person, like the triads of an average height person, right? And so it also indicates a slim figure. So uh, so it's a clear indication that what actually cluster one means, which is average height and slim build. Like so here are the interpretations like what it actually represents. So balanced, slightly slimmer, average height group, as you have seen in the chart. Let me like go there. Where is it? 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 Yeah, here it is. So yeah, you're seeing that everything is like normal or above medium. So it literally indicates that it's like characteristics of an average heighted person with a slim figure. Like, how do they say slim figure? Because look, the thigh thickness unit isn't like like nowhere to increment. It's like standing still in zero. So that means it's a slim person with average height. Yeah. So now, in cluster 2, what were we actually seeing? That the thigh thickness unit is at maximum and BMI unit is maximum. So we can actually guess that what this characteristics is actually implying. It can be like, healthy or broader fat person, perhaps, no offense. So let me see the cluster 2 here. So here, the shorter and heavier build, as you can see. So shorter and heavier means that the stature and grip reach are the lowest, as you can see. The stature and the what stature and shoulder, right? Yeah, stature and grip reach are the lowest, zero, zero, no increment, and also or the BMI is highest and indicating the heavier build to relative height. So as you can see, the BMI is the highest with the relative height, okay? And also the thigh thickness is highest, suggesting the broader lower limbs, which is like the legs, the upper part of legs, thighs are like in the maximum size. So what it that this is indicating as well. So it's obvious that it's referring to a healthy, shorter, uh, possibly a fat guy, perhaps. Okay. So and also the shoulder blade is narrower, like than cluster 0 shoulder breadth. Okay, where's the shoulder breadth? Shoulder breadth, shoulder breadth. Yeah, shoulder breadth also is like nowhere near. So yeah, it's relatable. So overall, this cluster possibly represents a shorter but broader individuals, possibly with higher masculinity and body fat. Muscularity and body fat. So this group may require a lower work surface but more space around seating and leg areas. And for cluster 1, as we saw, the average build where the person is like not too tall, not too short, but in average height and also has a slim figure. So what it actually indicates that stature and elbow height and shoulder breadth are moderate across the board, and the BMI is lower than cluster 0 and indicating a leaner group. And then the thigh thickness is the lowest, possibly implying the slimmer lower limbs, as I talked about. Like, look at the like the assessment here, like in the uh, chart. So, yeah, that's it. And also the thigh thickness is also I've said that before. And yeah, the vertical grip is reach is slightly below the cluster 0. So overall, that's that. And the cluster 0 was the taller athletic build, as you can see here. So here, as you can see. So that's it. And the interpretation of this is the cluster seems to represent the taller individual with an athletic and well proportioned physique. Like, come on, the people who are more taller, like has kind of a broader feature, refers to more athletic body, perhaps. So that's the thing. So this is my project, and I hope you liked it. And I'm going to bring more stuff like this. Yeah, let me know if I can improve in many ways. So yeah, thank you. Thanks for watching.